If it does not have that, okay? If it does not have that, you can do a print screen and print it out and turn it in, or figure out a way to email that to me.
Is it test points?
No, it's not test points.
It could be.
It could be. I don't know. I haven't really thought very much about it.
See?
I want to provide you with some extra points, and I haven't looked at it and exactly how I'm going to do it. Huh?
You can bring your grade up?
Yes.
Okay.
I want you to use the website. I want you to view the videos. I want you to take the practice tests, because it's only going to help you.
Yeah,
Okay?
exactly.
It's only going to help. All right. That's a cone. Any questions about cones? All right, let's talk about spheres.
We want to draw a sphere. Right.
Do we have a lateral height, a lateral area of a sphere?
Nope. Only area and volume.
Why not?
Because it's one thing.
Because there's no sides. A sphere has no base. There's no sides. It's just a ball. Okay? So let's talk about spheres. Okay, I will not provide any formulas for you on this one, because there is no general formula. There's only a very specific formula, so you're going to have to know it. But right now, I'm going to tell you what they are. Or you're going to tell me what they are. What's the area? How do you find the area of a sphere?
4 pi r.
What is he missing when he said
Squared.
4 pi r? Squared.
I didn't know if it was squared.
So there's only one dimension that you need to know when you're dealing with a sphere, and what is it?
Radius.
The radius. How do you find the volume of a sphere?
4/3 pi.
4/3 pi r
Cubed.
cubed. Volume is cubed. Okay, we're three-dimensional here. Once again, you will have to be able to tell me these. I'm not providing them for you tomorrow. Let's see what else you need to know. Yes. Do you think so? I wear red door. Ask her if that's what she wears.
I wear white door.
I've worn that since I was in high school, and I really, it's like my favorite perfume.
Ooh.
Come on. It's okay.
Red door. Okay. Let's talk about working with radicals real quick. Let's do a little review on that. If you're working your Pythagorean theorem and you come up with something that, say, is the square root of 80, and it needs to be reduced because radicals must be reduced to lowest terms. Austin, pay attention. First thing I need to do is break 80 down to its factors, okay? Because remember, if it's a square root, Jacob Taylor, what are you looking at on the computer?
Yes, I saw.
Okay, but I didn't mean the whole period.
I'm done now. I'm mixing it up.
Put it away. 80 is the product of what? Start easy. What's obvious? There's an 8 and a 0. 8 times 10. Okay? Is either one of those a perfect square? No. 8 breaks down to what? 2, 2, and 2. 10 breaks down again to 2 and 5. So all of these numbers are contained under that radical. Are they being added together?
No,
They're all multiplied. Under a square root, you cannot have a number appear twice because that is a perfect square. So every time a number appears twice, that is 4. And the square root of 4 is 2. Here is another 4, and the square root of 4 is 2. Now what do I do with these 2's?
Multiply.
You multiply them together. And anything that's left under the radical, if there was more than one number, you would multiply back together. So the square root of 80 reduces to 4 square roots of 5.
never understood that till now.
Now let's talk about adding or square. Let's square a radical. Suppose we just had our little 4 square roots of 5 and we want to square it.
Oh, I remember this.
Okay, Mason?
It'd be 8 square roots of 5.
It's not 8.
No,
And it's not
no,
8
no.
square roots of 5.
Wait.
16.
Yeah, 16.
What?
16 times 5.
16 times 5. Very good. Okay, because
It'd be 40.
it's 4 squared times the square root of 5 squared.
The square root.
Square root and square are inverse operations of each other.
So it goes
They
away.
undo each other. So you simply have 5. It's 16 times 5, which is 80. Isn't that what we started out with? Okay. All right? 80. So we've looked at reducing a radical. We've looked at squaring a radical. What about adding radicals?
What about it? Let's do that.
Can you add these 2 radicals together?
Yeah.
3.
Yes, you can, because the radical is the same, all right? It's like adding like terms. Now, this square root of 3 is simply a name tag. It does not become 6 square roots of 6 because
square
it's a name tag. We don't add the radicals together. Just like if this was 2x plus 4x, it's 6x. The x doesn't change. The radical doesn't change. It's the name of the term. I have 2 square roots of 3 plus 4 square roots of 3 for a total of 6 square roots of 3.
So the radical doesn't change
When you're adding, the radical does not change.
it multiplies.
When you're multiplying, you multiply. Okay? It's just like dealing with variables. You can only add variables that are alike. When you add, the variable doesn't change. You can multiply any variables together, and when you do so, you actually combine them. Okay? Now let me ask you this. What if I also had a little pi on the end of this? Can I still add them together?
Yeah.
And I still have pi on the end of it. Okay? But what if one of them had pi and the other one didn't?
Couldn't do it.
Then that would be your final answer. Because the name tags are different. These are different families. You cannot combine them. Okay? All right.